Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 1 to 5 of the Accuplacer Elementary Algebra placement test. All right, let's take a look at number 1. It reads, if A represents the number of apples purchased at 15 cents each, and B represents the number of bananas purchased at 10 cents each, which of the following represents the total value of purchases in cents? So a quick tip, when you're solving cost calculation problems, you always want to label your different quantities and unit costs clearly to avoid confusion. Okay? These are the steps we're going to use to solve this problem. First of all, we're going to write down our formula to guide our problem solving process. Then we're going to use our formula to find the total cost of the two items, namely bananas and apples. Okay? After finding the total cost of each independent item, we'll then find the total cost of both purchases combined. Okay, so let's go ahead and get started. The first step, step 1, let's write down the formula. What is the formula for total cost? The formula for total cost, is equal to the unit price of whatever item you're purchasing multiplied by the quantity. All right? So this is the formula we're going to be using for this problem. All right, so let's go ahead and find the total cost of both items. So let's start with apples. All right, so we want to try not to confuse our items here so we don't make mistakes. Okay, so let's start with apples. What is the total cost of apples? So let's write down the formula, apply this formula to this situation right here. So I'm going to write it in an abbreviated fashion. Total cost of apples, let's call it TCFA, is equal to the unit price of apples multiplied by what? The quantity or the number of apples. The same thing, okay? Number of apples you purchased. Now let's apply this formula for total cost of apple to this situation here. Okay, so for apples, what do we have? We need two things. We need the unit price for apples and how many apples we bought for the quantity. Okay, let's do that in red. So for apples, A represents the number of apples. So the number of apples or quantity of apples is A, and 15 cents each. Each means per unit. So this is the unit price. Okay, so let's apply that here. The total cost for apples is the unit price of apples, which is 15 cents multiplied by the quantity of apples, A. All right, so total cost of apples is the expression 15A. All right, now let's shift gears and take a look at bananas. All right. All right, so for bananas, we're going to use the same approach. We'll write down the formula. So for the formula again is going to be total cost for bananas is equal to the unit price of bananas multiplied by the number of bananas that was purchased. Okay? All right, so let's go back to the question. Try not to confuse things here. How many, what was the number of bananas that was purchased? B represents the number of bananas that was purchased. What is the unit price of bananas? 10 cents each. That's the unit price of bananas. Okay, so that is what we're going to use to set up the total cost equation for bananas. All right, so total cost of bananas is equal to the unit price, which is 10, multiplied by the number of bananas bought, which is B. If you multiply 10 times B, you have the expression 10B. Okay, so we're done with step 2. Now, step 3, we're going to find the cost of both purchases. All right, so we'll just simply add both of them. All right, so this is the setup. Total cost of both purchases is equal to the total cost for apples plus the total cost for bananas. Okay, so what is that? Um, it's simply the sum of these two results that we got here. Okay, so the sum of this one right here and this expression right here. So total cost for apples is 15a plus total cost of bananas 10b. All right, so our answer for number 1 is option letter D. All right, now let's take a look at problem number 2. This involves multiplying radicals. So the question is the square root of 2 times the square root of 15 is... Now one tip is that whenever you're multiplying radicals, the radicands must be multiplied with one another also. Don't add the radicands, that's not how you do it, okay? And when you multiply two radicands with one another, they remain radicals. The radicand signs do not cancel out. So that's something else you want to keep in mind. All right. Okay, so steps. First of all, we're going to write down the rule for multiplying radicals. It will address the misconception I highlighted just now. After writing down the rule, we are then going to apply it to this problem. Okay? All right, so step number 1, the rule for multiplying radicals. So the rules is as follows. If you have the square root of a times the square root of b, guess what this is? This is the square root of ab. The square roots do not cancel out. Please do not do that, okay? This is what some people do. Some students might think that the square root of a times the square root of b, these two squares cancel out and you have ab. That's incorrect. Okay, radical times a radical gives you radical. If the radicand is a squared quantity, then that square can neutralize this radical. This neutralization of a radical is not a result of the product, it's a result of the square of the radicand. Okay, so let me write that on the side. You can't do, this is wrong, but this right here, square root of AB quantity squared. You see, whenever I have the square root of a square now, these two cancel out, and this is AB. Okay, we do not have that here. So this is the formula we're going to use. All right, so let's apply it to this situation. So we have the square root of 2 times the square root of 15. Remember, we are multiplying, not adding. Okay, so it's going to become the square root of 2 times 15, which is the square root of 30. Answer is option letter C. All right, let's take a look at problem 3. It reads, what is the value of the expression 2x squared plus 3xy minus 4y squared when x is equal to 2 and y is equal to -4? Now this is a tip. When you're evaluating expressions at specific values, you always want to use parentheses. Okay, it is for your protection. Okay, it helps you avoid errors associated with grouping, order of operations, or resolution of negativity. Okay, so keep that in mind. All right, so these are the steps we're going to use to solve this problem. We are going to substitute the values of x and y into this expression here, using parentheses, of course. And then we're going to use the order of operations, please excuse my D&Sally, to evaluate the resulting numerical expression. Okay? All right, so we have the expression 2x squared plus 3xy minus 4y squared. We know that x is going to be attaining the value of 2, and y is going to be assuming the value of -4. So whenever you're evaluating expressions at particular values, you want to pay close attention to the negative input values, okay? Because that is a loophole that many students make mistakes with. All right, so what do we have here? We're going to have 2 parentheses 2 squared plus 3 times 2 times -4 minus 4 times -4 quantity squared. All right, so what just happened? What happened is that I substituted 2 for the x's in this expression and -4 for the y's. So what do we do next? We just finished step 1. What we're going to do next is we're going to use the order of operations. Please excuse my dear Aunt Sally to evaluate this. All right. So in the order of operations, please excuse my dear Aunt Sally. We don't have parentheses here, but we have exponents. Okay, so E is for exponent. That has a higher hierarchy. Is the next highest next to parentheses. Okay, so let's do the exponents first. So we have 2 times 2 squared is 2 times 2, which is 4, plus 3 times 2 times -4, minus, now when you square a negative, it becomes positive. So -4 squared is 16, so 4 times 16. All right, so next is multiply and divide. Now, multiplication and division, they have the same rank, okay? You can do both of them from left to right, whichever comes first. Now, in this problem, we just have multiplication, so all we'll deal with is the m. 2 times 4 is 8, plus 3 times 2 is 6. 6 times -4 is -24, so this is -24. And then 4 times 16 is -64. All right, so now we have a minus times a plus here. What is minus times plus? Well, there's a cool mnemonic device that can help you resolve the product of signs. It is known as the peace sign. So let's take a look at it real quick. Okay, so there goes your peace sign. So this is how you populate the open spaces. You have a minus, minus, and a plus. Now, what does this peace sign tell us? Well, it tells us that if you multiply minus times a plus, you get minus. If you multiply minus times a minus, you get plus. And minus times plus gives you minus. Okay? Another way to remember it is that anytime you're multiplying different signs, you always end up with negative. Whenever you're multiplying signs that are the same, you always end up with positive. So minus times minus, they are the same, gives you plus. Plus times plus, since they're the same, gives you plus. Minus times plus. Uh-oh, these are different. Minus times plus gives you what? Minus. And plus times minus, the signs are different, gives you minus. Okay, so don't forget that. Either you can use this nifty little peace sign here, or just use this rule for multiplying your signs. Okay, so let's go ahead and do that here. Plus times minus, signs are different, yields -24 minus 64. Okay, we're done with the multiplication division area of our order of operations. Please excuse my dear Aunt Sally. We're now going to move on to addition and subtraction. Now, for addition and subtraction, these two also have the same order. You can do them from left to right, whichever comes first. We have only subtractions here, so we just focus on the S. 8 minus 24. Whenever you're combining numbers with different signs, you subtract and keep the sign of the bigger, okay? So 8 minus 24, you subtract both of them, you get 16. But since the bigger number is negative, you retain the negativity, minus 64. Now, anytime you're combining numbers with the same sign, what do? You add and keep the sign. So negative 16 minus 64 is equal to negative 80. So the answer for problem, what number is this? Number 3 is option letter A. Okay, let's take a look at problem number 4. It reads, in the figure below, both circles have the same center, and the radius of the larger circle is r. If the radius of the small circle is 3 units less than r, which of the following represents the area of the shaded region? Now here's a quick tip. When you're finding areas of complex regions like you have here, it's always good to break it down into simpler regions first, consider the simpler regions, and then apply the solution to the complex case. All right, so always break it down, make it simple so that you don't confuse yourself. Now, steps we're going to use is we're going to sketch the components, the simpler regions that results in this shaded region right here, and then we'll label them using this information provided. After that, we're going to write down the correct formula for the situation, apply it to both cases, and then when we're done with the simpler cases, then we will combine them together to find the area of this composite shape, this complex shape right here. All right? Okay, now let's go ahead and get started. What we have is we have two circles. We have a bigger circle and a smaller circle. So it's highly recommended to draw. Okay, always sketch whenever you're dealing with geometry problems. Give yourself a visual so you don't make any mistakes. Okay, so this is our these are our two circles right here. Now what happens is that we're going to take the area of the small circle out of the bigger one, and that will give us the area of this shaded region right here. Okay, so you have the two circles. You have the bigger circle and the smaller circle. So if I take out the smaller circle out of the bigger circle like this, if I subtract the area of the smaller circle from the bigger circle, then we have this shaded region. Okay, so these are the two shapes that results in this complex shaded region. So what we're going to do is consider them independently, find their independent areas first, and then find the difference of the areas to find the expression for the area of this complex region here. Okay. All right, so step number 2 requires us to write down the formula for the situation. So we're dealing with area of circles here. So the area of a circle is what? Pi times radius square. So what does this tell us? It tells us that if you want to find the area of a circle, all you need is just a radius. Okay? All right, so this is a bigger circle, bigger, and this is a smaller. Okay? All right, so let's deal with the bigger circle first. So for bigger, area of bigger circle is pi r squared. Now the question is, what is the radius of the bigger circle? So let's say this is the center. We need to label the radius. Okay, oh, we skipped a step. We're supposed to label this first. Okay, so let's go ahead and label the radii of these two figures right here. So what is the radius of the bigger circle? It was provided to us in the problem. We were told that the radius of the larger circle is r. Okay, so for this larger circle, r, the radius, is equal to r. All right, so that's what we're going to use over here. R is equal to r. Now, for the smaller circle, the smaller circle has a radius that is 3 units less than big R, the radius of the bigger circle. All right, so the area of this one is going to be R less 3. Less means subtract 3. Okay? Perfect. Now, the area of a bigger circle is going to be pi r squared. But r is big R, so we have pi times big R squared. That's the area of the bigger circle. All right, how about the smaller circle? Can you see what the area is going to be? For the smaller circle, the radius is big R minus 3. 3 less than the radius of the bigger circle. So using the area formula here, the area of the smaller circle is going to be pi times radius square. What is the radius? The radius is this entire quantity r minus 3 square. All right, let's take a look at that for a second. So what did we just do here? All we did is we took the radius of the bigger circle, uppercase r, plug it in here to get pi uppercase r square for the area of the bigger circle. And then the smaller circle, we took the quantity r minus 3 and substituted it for r here in the area of the circle formula. So we have pi r minus 3 quantity square as the area of the smaller circle. Okay, so you see the power of breaking down complex problems into simpler cases. Attack them is that like a divide and conquer approach. Attack them in smaller pieces, and then you find out that you've been able to resolve the bigger problem. All right, so now we have the area of the bigger and the smaller. We're going to subtract the area of the smaller from the area of the bigger. All right, what does that give us? That gives us the area of the shaded region. So area of the shaded is equal to area of the larger or bigger minus the area of the smaller. Okay, so let's go ahead and do that. Area of the bigger is pi times uppercase r squared minus area of the smaller is pi times the quantity r minus 3 squared. All right, so answer for number 4 is option letter D. All right, let's take a look at problem number 5. It reads, the quantity 3x minus 2y squared is equal to. So one tip for this problem, problems of this nature, is that when expanding binomials, you always want to use arrows to help you keep track of what you're multiplying. You know, you want to give yourselves a visual system of keeping track of the terms that you're multiplying. Okay, it's a very good practice. Now, a word of caution. When you're squaring a minus b, the quantity a minus b, it is not the square of these two terms inside. A minus b squared is not a squared minus b squared. That's wrong. Okay, please do not make that mistake. That's one of the traps that's been set up for you in this problem. Okay, so watch out for that. That's wrong. All right, so the steps we're going to use in this problem are as follows. We're going to write the squared quantity in expanded form. Okay, this is the condensed form of a product. Okay, of an exponent. We're going to write it in expanded form. After writing it in expanded form, we're going to distribute the terms using FOIL, and then we'll combine like terms, and that will give us our final result. Okay? All right, so for this problem, we have 3x minus 2y quantity squared. If I want to write this in expanded form, what is it going to be? Remember, a square is the same thing as a times a. This is the expanded form of an exponent. So 3x minus 2y squared is the same thing as the quantity 3x minus 2y times itself, okay? 3x minus 2y. So you write it in expanded form first. Now what we're going to do is distribute these terms, okay? So we're going to follow this out. We're going to do first, outer, inner, and last. Now before I finish this problem off, let's take a step back. If I made this mistake here that I cautioned against, I distributed the square to these two terms, I will fall into trap letter A. That's a trap right there, okay? I'll get 9x squared minus 4y squared, which is wrong. Okay, so don't do that. Let's go ahead and distribute. So 3x times 3x is 9. 3 times 3, 9. X times x is x squared. 3x times negative 2y is negative 6xy. Negative 2y times 3x is negative 6xy. Negative 2y times negative 2y is minus times minus is plus. 2 times 2 is 4. Y times y is y squared. If you examine this closely, you'll notice that the two terms in the middle are like terms. Okay, so what do we do with like terms? As we talked about in step number 3, we combine like terms. Okay, so we will have, let's rewrite this. Let's write the squares first. 9x squared plus 4y squared. If I combine negative 6 minus 6, I get negative 12xy. Answer is option letter D. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this tutorial beneficial to you, please give us a thumbs up. We'll appreciate your positive feedback. Do not forget to subscribe for updates to the remainder of this review series. And more clips can be found on mathgotserved.com. We also have an interactive practice test. Go ahead and just click this link to gain access to more problems to help you get a great score on your placement test. Thanks again for watching, and have a wonderful day.